This is the world's largest 3D metal printer. It was built by Relativity Space, a startup that aims to print an entire rocket, including fuel tanks and rocket engines, in just 60 days.
I'm like looking inside a 3D printed rocket that is actually gonna go to space. This giant hunk of metal, it's unbelievable.
This video is sponsored by Omaze, offering you the chance to win a trip to space. More about that at the end of the show.
There's a lot of UV coming off the welds. You can film it, but don't look directly at it.
You get sunburned fast, so it's like you're suiting up to go in a volcano.
All right, we're gonna go in to the 3D printer and see how it works.
All right, so yep, just hold this up, don't look at it. We are in the printer.
I can see it over there.
If we walk around here, we can get up close. So that's the wire melting and the print head moving around. So that's the plasma discharge, and it's hard to tell, but it's doing things at every couple milliseconds. It's actually changing the electric waveform, which is how it's controlling the deposition so well.
Do you know the temperature of it? Like, is it just above melt temp?
It's just above melting for aluminum. Yeah, probably a few hundred degrees above.
The melting point of aluminum is 660 degrees Celsius, so the whole body of the rocket is effectively melted together one tiny bit at a time.
All the raw metal for the whole rocket that's printed is this. It's you know, we kind of joke it's like Charlotte's Web, like a spider silk, but this is an aluminum alloy that's on a wire spool. We actually print about 10 inches a second. So this wire is really going super fast, and then the combination of lasers and plasma arc discharge are working to melt both of them together at the same time.
So where does the wire come out?
So it's right there, and then the electric arc discharge happens right at the tip of the wire too.
This is a camera?
Yeah, that's a camera.
But why would you want to 3D print a rocket? Is it just because we can?
It's funny to me that you had this experience with 3D printing where you're like, oh, 3D printing is clearly the future. Whereas I feel like a lot of people's experience with 3D printers, as mine has been, it's like incredibly frustrating. I feel like 3D printing is that thing that seems like it should be great, and yet whenever I try it, I don't get a result that I'm happy with.
Yeah, I know. I can tell you we had plenty of experiences the first couple of years where we ended up with a pile of metal and it didn't work.
But there are actually good reasons to 3D print a rocket. A rocket has four major systems: payload, guidance, structural, and propulsion. The bulk of the rocket is made up of the propulsion system, including the propellant tanks and the rocket engines. Cryogenic fuel and oxidizer are pumped through an injector into the combustion chamber where they react, releasing an enormous amount of heat. This causes the exhaust gases to expand, exiting the rocket nozzle at high velocity. The faster this exit velocity and the higher the mass flow rate, the more thrust that can be generated. So rockets are huge, complex engineering projects, which up to this point have largely been manufactured using traditional techniques. That means before you can build the rocket, you first have to build the tools to build the rocket. For example, to build NASA's next huge rocket, the Space Launch System, or SLS, they first needed to construct the Vertical Assembly Center, or VAC. This is a 170-foot tall tool for welding together the domes, rings, and barrel sections of the rocket's fuel tanks.
They built that like an aerospace thing, and they've had to spin up all these custom tooling designs and validate that those work before it actually starts building the rocket. And they've finally got one being assembled on the pad after 11 years of development.
In contrast, Relativity Space, the company, is just 5.5 years old, and they plan to launch their first rocket this year.
I see this as a like old engineering style versus Silicon Valley style of build something, figure out what's wrong with it, and build another thing that fixes those, right? The difference is I've always done that with software. These guys are doing it with aerospace hardware.
So this is the actual rocket tank structure of what we're going to be launching to orbit at the end of this year. So this actual thing is launching to space.
That will go to space.
This will go to space, and it's by far the largest 3D printed product really of any type ever made that's going to fly. I think maybe of any type in the world.
But it still looks 3D printed, like you can still see the layers.
Yeah,
right?
you can still see the layers. It only adds an extra 5 to 10% of the mass with the roughness. When you actually cross-section the material and look at the machine parts of it, it looks like normal metal. Like actually at this end, this is printed as well. We just machine it afterwards. So it looks like normal metal in the joint sections.
Does the surface roughness cause any aerodynamic problems?
No, none at all. Yeah, it's actually the exact same aerodynamically. This whole thing, we simulate the print before printing, because if you just printed the 3D file and said press print, you would end up with a printer that's warped and like material falling all over the place. It wouldn't actually work. So we've invented software that reverse warps the whole part before printing it. So the robots are actually doing this really wobbly, weird shape, but then it is actually perfectly straight within a human hair across the entire length. As it cools,
the warpy thing turns into the...
And we simulate all of that. So it's a big computational solver that simulates it. And there's many, many other problems we've had to solve to actually get printing a rocket to work. But it's all these little pieces over the last couple of years. And we've really started to hit some breakthroughs, which is also why now you see a whole rocket. Yeah, you can step up here actually if you want. Yeah.
Hello. I'm like looking inside a 3D printed rocket that is actually going to go to space.
Yes.
This giant hunk of metal. It's unbelievable.
Yeah.
There's like rings inside.
Those are printed in stiffeners, and so those help prevent the rocket from buckling and crumpling. So if you had a Coke can and didn't pop the tab, if you try to step on it, it's almost impossible because there's pressure inside that keeps it from buckling. But then when you pop the tab, there's no pressure and you can crunch it super easy. It's not hard at all. So rockets are the same. The 50 psi of pressure, which is about the same as a car tire, keeps it inflated and keeps it from crumpling. But then those stiffeners also help keep it rigid. Okay. Yeah, so believe it or not, a rocket tank is thinner versus its diameter than a Coke can. So when you look at a Coke can, how big it is and then how thin it is, a rocket tank is actually thinner than that. So yeah, it's pretty light. It has to be very light.
Sure.
Aerospace companies started using metal 3D printing over a decade ago to construct small, complex parts, for example, the injector.
That is the most important part of any rocket engine, where you're basically got to take the liquid propellant and turn it into a fine mist that mixes really rapidly. And those have actually been transitioned to 3D printing all over the industry.
Traditionally, something like this, it's a rocket engine injector, so it mixes liquid oxygen and liquid methane propellants together, and this is what actually produces all the fire and flame that is in a rocket engine. Traditionally, it would be over 1,000 individual pieces, and it would take 9 months. But here, we're 3D printing the whole thing in one piece. It takes 2 weeks, and it costs 10 times less.
One of the big benefits of 3D printing is reducing the number of parts. Have you ever thought about how inside a rocket's combustion chamber, it gets really hot, up to 3,500 Kelvin? That's hot enough to melt virtually any metal. So how do the combustion chamber and rocket nozzle not melt? Well, the answer is they're cooled by passing the cryogenic propellants over them.
On the space shuttle main engines, I love to talk about them because inside those engines, it's hot enough to boil iron. On the outside, you can freeze stuff to the exterior of this because you're running liquid hydrogen through these things. But to make those, you basically had to take thousands of very small pipes, and then you would form them into the shape of the combustion chamber and the nozzle, and then you would braze weld them together, and this was a ridiculously labor-intensive task. You would have 1,080 individual pipes running up the side, all having to be welded together to make the combustion chamber and the nozzle on the space shuttle engines. So you can actually 3D print these things.
This is a rocket nozzle being 3D printed, and you can see the channels for the cryogenic propellants being printed right into the single part, instead of having to add 1,000 pipes on the outside. Smaller parts like these are typically 3D printed using metal powder and lasers.
So you can see the cooling channels are all being built as the one piece. So
Yeah.
this is a nozzle. It really just lays down a layer of powder that's about a 20th the thickness of a human hair. So it's really, really fine layers, just over and over and over and over relentlessly for probably about a week or so, and then out comes a rocket nozzle. All printed as one piece. It's way cheaper than traditional. And this has 4 lasers going at once.
That's amazing.
I get asked a lot, well, aren't 3D printed metals not very strong, or how can it actually work? But the printed materials are stronger than they would be built traditionally. Actually, it's counterintuitive.
It is.
Because we develop our own custom alloys in-house. So we have a whole material science team just developing our own alloys for 3D printing. And the fact that it melts and then cools and solidifies very, very quickly, you can take advantage of that physics principle to get really strong alloys.
Another major benefit of 3D printing is that it allows for rapid iteration. You can build a part quickly, test it, and then redesign rapidly and print again.
So this is a version of the engine that's about 3 years old at this point, but what's amazing is when you actually look at the engine design today, it looks entirely different than this. So each version we build, we can iterate and make better. So that's the other, when we say software-driven manufacturing, that's really what it is. Since you don't have fixed tooling, all the part geometries are just controlled via the CAD model, and then the printers just print direct from file, essentially. It means you can actually change the design extremely fast. So building a whole engine only takes us about a month. So then a month later, you can do a better version, and a month later, a better version than that. So this particular one will actually be, I believe, one of the first flight engines that's actually launching to orbit on our first rocket.
So this tubing, not 3D printed, right?
Not today.
Okay.
And the future versions, we're actually integrating that into the printed housings, and we're going to have a way that that's all printed too.
Perhaps the biggest impact of the 3D printing approach could be to totally transform what a rocket looks like. With 3D printing, engineers can build parts that would be impractical or impossible with traditional techniques. Smooth, curvy, bio-inspired designs are just as easy to print as ordinary structures.
This is actually part of our next rocket, Terran R, so it's even larger.
This is like the base of a tank?
Yeah. So it's going to go out, it's almost done printing, it's going to go out about to here, so it's 16-foot diameter, but it's almost like a shell.
I was gonna say, like, this reminds me of suddenly we're in The Little Mermaid or something.
Yeah, it's just for stiffness though.
It's not that you plan to make it bio-inspired, it's that that structure is actually the optimal structure.
Yeah. We're actually designing many features in the rocket that could not be manufactured unless it was 3D printed, which is one of the secret sauces of why you had to build a whole company around it, is because our rocket actually looks entirely different 3D printed than it does traditionally. Like, in my mind, it's been more akin to like gas internal combustion engine to electric. Really, people are trying to put batteries and electric motors into existing products for decades. Like, everyone knew electric vehicles were the future, but Nissan and Ford had really not compelling products for a long time. It wasn't until a company came along, called Tesla, that decided, well, actually, the shift to electrification means the batteries, the electric motors, the factory, the design of the product, how we're actually going to scale the company, the supply chain, all of it's different because of electrification. I mean, that's in some ways the dirty secret of electric cars and why they're able to be automated in production, because the part count is so much lower. So for a fully 3D printed rocket, we have 100 times fewer parts, which is what we're guiding to. There's no fixed tooling in our factory at all, unlike the rest of aerospace that's still really 60 years later, even since Apollo, building products one at a time by hand with hundreds of thousands to millions of individual parts. And no one's really changed that paradigm of how an aerospace factory actually fundamentally works. Yeah, this is the new fully 3D printed rocket. So yeah, we'll have dragonfly wing type structures, and we're building it still, but that's the first one, and then that's that one for scale. So yeah, it is definitely bigger. Yeah, so our rocket is named Terran 1 and Terran R, and then our 3D printer is Stargate, so all the things at Relativity are named after StarCraft. So yeah, of course the Stargate printer was what the Protoss used to warp in spaceships, and so that's what's warping in spaceships at Relativity. We have a system in our avionics called a pylon that we have to build a lot of, so we always joke we have to construct additional pylons. Most people don't know how a rocket's built traditionally at all anyway. And I think a lot of people assume it's rockets, so shouldn't it be already very advanced and robots everywhere, and Elon's got SpaceX and Tesla, so doesn't SpaceX just look like Tesla with all these robots and automation? But that's really not true. I mean, aerospace hasn't adopted automation at all.
One of the issues, right, is that you're not making a lot of rockets.
Right.
So there's no incentive to like figure out how to tool up a factory to like pump out rockets like 100 a day or something.
Exactly.
Like you would for cars.
Exactly. You're not making a lot. Even with commercial aircraft, you're not making nearly as many. And there's orders of magnitude more parts and complexity. A commercial aircraft has several million individual parts. So to have robots assemble several million parts when an automobile has tens of thousands is completely different. It's a much harder problem. So that's where 3D printing is automation for aerospace, because you're not assembling all those parts with robots like you would with a car. You're assembling them in the 3D file, and then the printer just prints them assembled.
The plan for Relativity Space,
Yep.
Is it low Earth orbit or is it going further than that?
So for Terran 1, it's mostly low Earth orbit, the first rocket. Terran R can actually send payload to the moon, to Mars. I mean, it's pretty huge. I founded the company because I really thought that there needed to be dozens and hundreds of companies making Mars happen. We're focused on taking this 3D printing tech and what we call the factory of the future, and one day shrinking it down to something we'll actually launch to Mars and build an industrial base. So that's the long-term vision of the company, is build the industrial base on Mars. In many ways, this factory is just a prototype. It's still far smaller than a traditional factory. It's far lighter, and I think it's inevitable someone has to build this company.
I don't know that in 10, 20 years that you will be 3D printing rockets all the time, because if you are flying lots of rockets, it becomes cheaper to have a dedicated machine for it. I do think that as a company, they are well placed, because even if Terran fails to capitalize on the market, even if nobody wants to use it as a launch vehicle, they are clearly now the world experts on 3D printing rocket hardware, because they've done everything, right? They've tried to apply 3D printing to places where a lot of people dismissed it. So I think they're sort of secure as a company. Whether we will see rockets being 3D printed all the time, that's a good question.
There's been a lot of talk recently about billionaires going to space.
Yeah.
Will a 3D printed rocket make it possible and a lot cheaper for me to go to space?
Yes, I mean, certainly what we're doing is lowering the cost. So our rockets are costing about 5 times to, I believe we can get to 10 or even 100 times cheaper with a fully reusable rocket than what we have today. So it can definitely climb down the cost curve. But I also think going to Mars and the first people that are going, it really is about what is the point of being a human being. Like for me, why go to Mars is if we were having this conversation and 1 million people were living on another planet, I think it would expand the possibilities of human experience and what it means to be a person. Like we'd have YouTube channels on Mars and people sharing what life on Mars is like versus Earth, and there'd be long distance Amelie, like love story. Like I think there's just a lot of richness in what human culture and society can be about. Yes, I think there's criticism about billionaires going to space, and I don't agree with all of the projects need to actually add up to some vision that is meaningful. I think that's really important. But I do think going to Mars is really just about, we've lived for generations on Earth, so what's it all about? Like why do we want to keep improving and getting better and furthering society on Earth? So for me, it's pretty existential, what it means to be a human being.
Hey, this video is sponsored by Omaze, offering you the chance to win a trip to space. The winner will get 2 seats on one of Virgin Galactic's first commercial space flights, meaning you and a guest will travel 80 kilometers up in the sky. You'll get to see the curve of planet Earth, experience weightlessness, and become one of the few people in the world to have gone to space. And you'll also get to join Sir Richard Branson for a personal VIP tour of Spaceport America. The flight is estimated to take place in early 2022, so enter at omaze.com/Veritasium for your chance to win. Now, Omaze partners with charities, in this case Space for Humanity, an organization whose mission is to expand access to space and train global leaders in the eventual goal of creating a sustainable future. So part of your contribution supports this cause. To potentially win a trip to space and support Space for Humanity, a great cause, go to omaze.com/Veritasium. I will put that link down in the description. So I want to thank Omaze for sponsoring this video, and I want to thank you for watching.